Welcome back to the Deep Dive. Today we are looking up, and we're not just, stargazing. We are grabbing the sky with both hands and shaking it until the loose change falls out.
That's one way to put it. It's a fascinating topic today. We're looking at a stack of source materials that delve into what they call ancestral astronomy.
Right. And I have to say, this is definitely not the astronomy you get in a typical university lecture.
Oh, not at all.
No. I mean, usually when we talk about space, we talk about Earth like it's this lonely spaceship, a blue marble just cruising around the sun.
And the moon is just this dead rock tagging along for the ride.
Exactly, like a quiet passenger. But these documents, they really challenge that whole picture. They argue the Earth's space-time weave, the fabric of our reality, it's not a solo act.
No, it's not. The core premise here is that the Earth and moon function as a binary system. The sources describe it as a co-creative relationship.
Co-creative. I really got stuck on that word. It implies, agency.
A partnership.
It's a bit of a mind bender compared to standard astrophysics, where it's all just gravity and cold mass.
Yeah, well, that's because we're looking at this through a very specific lens. This isn't just modern mechanics. We're diving into a system that unifies scientific calculation with a spiritual understanding.
It sees them as two sides of the same coin.
Exactly.
And before we lose anyone who thinks this is just going to be about, like, horoscopes or vague vibes, this is surprisingly math-heavy. There is a lot of geometry in these pages.
There is. And the key difference, and this is so crucial for you to grasp right away, is the perspective. Modern science is generally heliocentric.
Right. It looks at the solar system from the sun's point of view.
Or from outside the system looking in. But ancestral astronomy, as it's described here, is geocentric.
Which, I'll be honest, that word usually sounds outdated. Like, oh, those ancient cultures thought the Earth was the center of the universe.
But that's the misunderstanding, isn't it? It's not about arrogance or ignorance. It's about observation. It asks, what do the mechanics of the universe look like from right here?
From standing on the surface of the Earth.
Yes, it's a phenomenal observational science. And when you take that perspective, the moon, it stops being just a satellite. It becomes a fractal.
Okay, that word fractal is all over this source material. The moon is a fractal of the Earth.
Let's unpack that, because when I hear fractal, I think of those trippy, infinite zoom videos on YouTube.
Right. Well, in this context, a fractal implies a self-similar pattern.
Yeah.
The source argues that the moon reproduces, on a much smaller scale, the microcosm, the exact same order and harmony that the Earth experiences in its bigger journey around the sun.
The macrocosm.
The macrocosm.
So the moon is basically holding up a mirror to the Earth. It's like it's saying, I'm going to do locally what you are doing globally.
Precisely. It's a structural echo. The moon mimics the Earth's relationship with the sun, but it brings it down to a scale we can actually feel and measure daily. And that's our mission for this deep dive, right? To decode that echo. We're going to break down the mechanical cycle, tides, phases, nodes, eclipses.
But we're going to do it through this ancestral mathematical framework.
And a quick warning to everyone listening. The math here uses a specific baseline that, well, I hadn't really thought about before. The number 1440.
The heartbeat of the system.
It is. I actually grabbed my calculator when I saw this just to double check. It's like, okay, 24 hours in a day times 60 minutes.
And there it is.
1440. It seems like such a mundane number, just a result of our clock. But the source treats this number as something structural.
Because in ancestral astronomy, 1440 isn't just a measure of time, it's a measure of space. It is the standard unit of the Earth's rotation.
So it's not just counting minutes.
No, you're measuring a frequency. The source says these ancestral cultures, the Maya, the Aztecs, even Celtic traditions, they encoded these rhythms into their scriptures and oracles. Their spiritual life was grounded in observing this 1440-minute rhythm.
The beat of the Earth's spin.
So,
okay. We have our baseline. Earth spins once every 1440 minutes.
Yeah.
Simple enough. But then the moon enters the picture and it kind of messes up the perfect math.
It doesn't mess it up. It complicates it into a rhythm. And this brings us to the first big cycle in our stack, the rhythm of the waters, the tidal cycle.
Right. Now, most of us know tides are caused by the moon's gravity, but the explanation here is much more mechanical. It feels like a gear system.
It is mechanical. You have to imagine two movements happening at once. Movement A, the Earth is spinning on its axis. That takes 1440 minutes.
Okay, got it.
But movement B, the moon is not standing still. While the Earth is spinning that full 360 degrees, the moon is traveling forward in its own orbit around us.
So, If I'm a spot on the Earth, they say, I'm standing on a beach looking at the moon, and I spin around for 24 hours when I get back to where I started.
The moon isn't where you left it.
It's moved.
Exactly. It's running away from you in a sense.
Right.
The source calculates this precisely. While Earth does one full spin, the moon moves forward by about 13 degrees. In time, that translates to a lag of 52 minutes.
There it is. The 52-minute lag. This was a huge aha moment for me reading this.
That is the magic number for the tides. Because the moon has moved ahead, the Earth has to spin an extra 52 minutes just to catch up to the moon's new position.
It's like chasing a bus that keeps creeping forward every time you get close to the stop.
That's a perfect analogy. You have to run a little further every day. And that desynchronization is why the tides shift. A tidal day isn't 24 hours. It's 24 hours and about 50 to 52 minutes.
And that daily advance is what mathematically confirms the moon's full orbit takes around 28 days.
Correct.
But the text didn't stop with the math. This is where it gets really interesting for me, because it blends that hard geometry with this very poetic, almost romantic imagery. Did you catch the metaphor about the Earth's face?
Yes, it was beautiful. It asks us to imagine the Earth's surface as its face. As the Earth spins, it wants to keep its eyes on its child, the moon.
It doesn't want to lose contact.
And the text says the waters are like a mantle or a cloak that the Earth uses to reach out, so the tides aren't just water sloshing around.
In this view, it's a relational gesture, a push and pull of connection.
The Earth trying to bridge the gap. It's reaching out with its oceans.
Wow, and the source emphasizes that we can't study the physical agitation of the waters without the psychic or spiritual influence. I mean, if the ocean is being pulled by this 52-minute delay,
And our bodies are mostly water.
then we're being pulled too. It suggests our internal rhythm, our biological clock, is synced to this lag, whether we realize it or not.
It reframes gravity from just a force to a relationship. It's the Earth and moon dancing, and we're all living on the dance floor.
Okay, so we have the tides sorted, 28-day cycle, driven by this game of catch-up. But this leads us into what the sources call Cycle 2, the Great Divergence. And this is where I got confused at first, because the numbers, they don't seem to match up.
This is a really common point of confusion in astronomy, yes.
If the moon orbits the Earth every 28 days, why is the cycle of phases, new moon to full moon and back, about 30 days?
Roughly 29.5 to 30 days, yeah. It's called the Lunation cycle.
So why the discrepancy? If the orbit is 28, why does the visual cycle take 30?
Now, if you open a standard physics textbook, it'll tell you it's because the Earth is moving around the sun.
Right, I remember that from school.
So by the time the moon completes an orbit, Earth has moved, and the moon has to travel a couple extra days to get back in line with the sun for a new moon.
But our source material says, hold on, look closer.
It does. It acknowledges the sun's role, but ancestral astronomy emphasizes a different factor, the obliquity of the orbital planes.
Obliquity, that's a fancy word for a tilt.
Essentially, yes, the inclination. The source describes this fascinating Maya drawing to illustrate it. It shows two men pointing at each other, holding a rope.
It looked like a tug of war.
It represents tension, the tension between two different perspectives or two senses of space-time. The idea is that planets don't travel on flat, rigid tracks like a toy train set.
They're on flexible, oblique planes. That sounds a little precarious for a planetary system.
It's actually necessary for stability. The text says if the connection were rigid and flat, gravitational stresses could just tear the system apart. So they travel on these tilted, flexible planes to avoid deorbiting.
So this tilt, this obliquity, it acts as a shock absorber.
In a way. But more importantly for us, it distorts our perspective from Earth. Because we're looking at the moon from a tilted angle, the geometry itself creates a time difference.
So the difference between the 28-day orbit and the 30-day phase cycle isn't just about the sun. It's because we're viewing the moon through a distorted, tilted lens.
Exactly. The geometry of the tilt stretches the apparent time. We're seeing a projection, not the raw movement.
This leads perfectly into the next bit because the source makes this really bold claim.
Right.
It basically says the phases of the moon, new moon, full moon, all of it, are an illusion.
Illusion might be a strong word, but they are certainly a trick of perspective. This is cycle 3, Lunations. The text calls it a play of light and shadow.
So it's not the real orbit. It just shows our perspective of the light.
Think about it. A full moon is just sunlight bouncing off the surface when the alignment is right. It's a visual cycle. It's superficial in a way.
It tells you about the lighting, not the structure.
Precisely. If you want to know where the moon really is in space, its structural location, you have to look at cycle 4, the nodal cycle.
The nodal cycle. Okay, for a lot of listeners, nodes are probably a new concept. We know full moons, we don't talk about nodes at parties. How do we visualize this?
Okay, let's go back to the geometry. We have these tilted orbits. Imagine the Earth's orbital plane around the sun as a flat sheet of paper extending out into space.
Okay, I've got a sheet of paper floating in the dark.
Now, the moon's orbit isn't lying flat on that paper. It's like a hula hoop that's tilted relative to the paper. So as the moon goes around its hoop
It has to pass through the paper.
twice, it has to pierce it twice every orbit.
Once going up and once going down.
Exactly. When it crosses from below the paper to above it, south to north, that's the north node. When it crosses from above to below north to south, that's the south node.
The source described this as a weaving pattern.
That is the core image of the space-time weave. The moon is literally stitching the fabric of space by diving up and down through Earth's plane, up through the north node, down through the south node.
So if the phases, the lunations, are just about lighting, the nodes are about actual 3D coordinates.
Yes. Lunation is, what does it look like? Nodal is, where is it really? And this distinction is absolutely critical because you can't understand the most dramatic lunar event of all the eclipse without it.
Let's talk about eclipses. Cycle 5. I think most people see them as these random, rare events, like, oh, the sun disappeared, weird.
The source is very firm on this. Eclipses are not random at all. They are the result of a precise formula. They're geometric intersections.
And the text gives us the formula. It's like a recipe. You need 2 specific ingredients.
Right. Ingredient A. You need the lunation cycle to align. So you need a new moon for a solar eclipse or a full moon for a lunar eclipse.
Well, we get those every month. And we don't get eclipses every month, so that's not enough.
Exactly, because you also need ingredient B, the nodal cycle. The moon has to be physically crossing that sheet of paper at the exact same moment it aligns with the sun.
So it's the intersection of the shadow-light cycle with the spatial intersections.
Think of it this way. You can have a full moon, beautiful and bright, but if the moon is at the top of its tilted hoop, too far north of the paper, the Earth's shadow just passes right under it. It misses. No eclipse.
And if it's too far south, the shadow passes over it.
Correct. But if the full moon happens right as it hits the node,
Click.
click. Everything locks into place, the shadow hits, and you get an eclipse.
It's amazing to think of it as a mechanism, a giant celestial clock where the gears only mesh perfectly once in a while.
And that's the heart of ancestral astronomy. It removes the randomness. It sees these events, tides, phases, eclipses, not as separate things, but as layers of one unified system.
It connects back to that intro concept, the space-time weave. You can't just pull one thread.
You can't. You have the physical agitation of the waters, the tides, you have the visual cycle of light, the lunations, and you have the structural geometric cycle, the nodes, all woven together.
And the source material really emphasizes that this isn't just academic. It says we cannot study the physical life of Earth without considering the psychic or spiritual influence of these mechanics.
That stood out to me as well. The text speculates that without this moon, without this specific relationship, the web of space-time would be dull, or maybe life wouldn't exist at all.
It's the tension between them that creates the rhythm of life.
It is. We look up at the moon and just see a rock, but this perspective suggests it's the loom on which the fabric of our reality is woven.
So our fluids, our timekeeping, our sense of up and down, it's all defined by this partner in our orbit.
It's a binary system in the truest sense.
Wow. Okay, so we've covered the 1440-minute day, the 52-minute tidal lag, the illusion of phases versus the reality of nodes, and the formula for eclipses. It feels grounded.
It feels grounded because it starts from where we are. It honors the human perspective, the geocentric view, while demanding that mathematical rigor.
Before we wrap up, I want to leave our listeners with a thought that came to me while reading about the flexible planes. It's been nagging at me.
Go on.
The source made such a big deal about how the phases of the moon, the thing we see most clearly, are actually a distortion caused by our tilted angle.
We think we're seeing the orbit, but we're just seeing a trick of light and perspective.
Exactly. So here's the thought. If the most obvious pattern in our night sky is actually a distortion, what other obvious patterns in our daily lives, our relationships, our societies, are actually just distortions?
That is a profound question.
What else are we seeing incorrectly just because we're viewing it from a tilted angle? Maybe we're seeing phases in our own lives, ups and downs that feel real, when we should be looking for the nodes, the structural reality underneath it all.
We often assume our angle of vision is the objective truth. But as this shows us, sometimes you have to look at the geometry behind the scenes to really understand what's going on.
You have to understand the tilt to understand the time.
Precisely.
Maybe we all need to check our own orbital planes every once in a while. Make sure we aren't just looking at the shadow and calling it the truth.
I think that is excellent advice.
Thanks for diving deep with us today. Keep looking up and maybe try to see the geometry behind the light.
Goodbye, everyone.
See you next time.